what homework looks like, and then I have the book nearby if we want to look at homework really fast too. I don't mind, since it's not in Google Classroom yet, if you guys want to write it down, I can pull it up real fast. Because I think you guys already wrote this yesterday, right? Well, Monday. Here we go. That's not you guys. This is you guys. CalcBC. Homework sheets. Chapter 11. Let's see what this chapter entails, because this is our last one. We might want to know how much work there is. I updated your calendar this morning. I think the test is in 2 weeks. It's right before, yeah. Quick quiz for AP Prep. What? That's just the title of the section. It's okay. I made it a homework. Don't worry, don't worry, don't worry. Which means it might be tricky. And we definitely have some AP practice to go over, kind of like last chapter also. We are going to get really bogged down, though, guys, right here, the last 2 sections. The first section should be pretty straightforward, pretty basic. Even the second section, I can't talk today, I'm sorry, should be pretty straightforward. But this section, whoo, polar area. It's going to be a party. You guys are going to need to start bringing your calculators, especially for the AP practice in the polar area. Not that you're allowed to use it every single time, but when you do use it, the AP sure likes to get tricky. And so there are a few things, especially with those of you guys, most of you guys I didn't have for pre-cal. We're going to need to look at a few things, especially with polar graphing on our calculators. So today is not a big deal. Don't go running to your lockers to grab it. But start bringing your calculator, please, to class so that we can work through those sorts of things. All right. This is what homework? Number 47? Is that right? Oh, is it for you? Hold on, I can check too. I can look at the bottom. Yeah, 47. And we didn't end up having a test review, so that was a little weird, but you guys don't number those anyway. So this is chapter 11. We can just call it polar and parametric. We talked about it yesterday, how you can also technically call it vectors, but parametric is vectors. Or I should say, the vectors will include parametrically defined functions. Guys, I need you to think of something, though. In your notes, when I say function, let's just think algebra. When I say function, what should you think? F of x, that's function notation, a function, a y function in terms of x, but what else should you think? What does it mean to be a function? Vertical line test, has to pass the vertical line test. Give that to me in words. What is true if it's passing the vertical line test? Yeah, for every input, there's one unique output, or for every one x, there's one y that comes out. Why is that important? If you were to put in something to your calculator like 2 plus 2, and it gives you like, well, sometimes it's 4, and sometimes it's 8, and sometimes is that going to be very helpful? How is the calculator even going to be able to answer if there's more than one solution? Now, do you guys remember trig inverse? That's where we really butted up against the idea of a function. Trig inverse, don't you get something like sine of x or sine of theta is equal to 1/2? What's the dilemma with that question or that equation? The answer the calculator will give you is only in the first and fourth quadrant, because first quadrant sine is positive, fourth quadrant sine is negative. So if we're only looking there, one unique input, 1/2 to an inverse sine, will get one unique output, either the first quadrant angle or the fourth quadrant angle. But what's true about trig in general? How many answers are there to sine equals 1/2? Infinitely many. Because you can be in the first quadrant or the second quadrant or coterminal angles of the first and second quadrant, so plus 360n or 2 pi n. So there are infinitely many answers, which is why the inverse trig function, the second sign button in your calculator, is defined to only look for one unique solution, even though there are infinitely many, right? And we had to kind of butt up against that when they would say, find one answer, okay, find 10, and you're like, oh, great, well, that's fun. And the different intervals, et cetera, et cetera, et cetera. Sorry, 7:45 a.m. And it is officially, nope, new chapter. Sorry, chapter 11. What did I call this? Parametric and polar? Parametric and polar. Let me finish my thought real quick. So, functions, one unique input, one unique output. It's going to be tricky because yesterday I told you when, I think Justin was asking me about parametrically defined, or maybe Maggie when you're talking about two-dimensional motion. I mentioned how with parametric functions you can go in circles. Wait, no, that doesn't make sense. One x is paired with one y. Not functions. We're not allowed to call them functions. They have to be equations if they go in circles. They don't all go in circles, but they can. So wait, if they can go in circles, calculators out if you have one. If you don't, look on with someone in your group. I want you to go to parametric mode. Some of you might be like, circles? We can't get circles. What are you talking about? If they're functions, how do we get circles? Just a quick intro, just kind of reminding us as to how these work and why they're called functions if we're getting things that fail the vertical line test. I want you guys to graph x is equal to, I don't know, let's do an ellipse. Let's have fun. How about 3 cosine of t and y is equal to 5 sine of t? Parametrically defined because we have one set of functions put together to make one path, horizontal, vertical components. How do I know this is an ellipse? Anybody know? Guess what honors pre-cal is starting right now? Oh God, that. Otherwise known as conic sections. There you go. How did I know this was an ellipse? Because x squared plus y squared equals r squared is a circle, but this one's not a circle because are the coefficients the same? No, so I can't multiply by 9 or multiply by 25 to get a circle, but isn't it just a ellipse instead? How did I get him? I solved for cosine. How did I get him? I solved for sine. And I plugged and chugged. Anyway, what does your calculator show you? Does it show you the full ellipse? If it doesn't, you would need to go and change your T min, T max to include more angles to be broader, wider. Ooh. Try standard. There you go. However, wait a minute, hold on. Does some of your guys look like circles even though it's supposed to be clearly an ellipse over 3 up 5? Why? Look at your window. Isn't your window a rectangle? But doesn't standard fit in 10 by 10 on both axes? So doesn't that squish your shape? Zoom. Isn't there a zoom square? A zoom square says, pretend I don't have a rectangular, pretend I have a square, aka make all the units equally spaced so the x's can be negative 10 to 10, but look at your window, aren't the y's different if they're equally spaced? If you do zoom square, it should look a bit more like what it actually is, true to, I think it's zoom square. Yeah. Yeah. So, and then check out your units. Now they should be equally spaced. The y's aren't squished anymore. Because when they're squished, it looks like a circle. It's really an ellipse. But pause. Back to my original question. How can we call this a function? Or I should say parametric functions. How can I say these are functions if it fails the vertical line test? I mean, there are two separate. So some of you are maybe thinking like a top and a bottom, but that's not it. Yeah, two separate comprising one. But it's not like a plus or minus square root where it's like, okay, I can explain away this and I can explain away that and put them together. Like it's not that the x gets the top half and the y gets the bottom half. Riley, how did you define a function? What's my input? Not x. So the definition of a function changes when your independent variable changes. So I'm not putting in x's, I'm putting in t's. So does each x need to have a unique y? No. Each t needs to have a unique position. So when t is 0, where is it? When t is 0, what's my position? What's cosine of 0? 1. So wouldn't it be 3, 0? Aren't I right here at 0? Can you guys go to your graph and can you go before the equals, before the y1, the x and the y, and can you change, isn't there like a line, can you change it to be that cool little dot with a tail? You know what I'm talking about? Yeah. Change it to be this guy. Unless it doesn't. Does it not? Parametric mode? I thought it did. Go back before, and instead of making it solid dotted, oh, go back, and then if you hit enter, go find me the dot with a tail. It means it's going to show you the positions at the different times of your window. Now go to your window and make t equals 0 as your beginning, t min in your window. Make t min 0 and make t max, I don't know, what do you guys want, 10 seconds, 20 seconds? Well, we're doing angles, 2 pi, 4 pi, 6 pi. And then hit graph. Do you see the little car on the track? Do you see him starting here? Where does he go? Does he go up and to the left? Does he go down? Okay, like this way? Do you see it? We could actually show. Do you have your little circle with a tail? Sometimes I'm going to change it. See? Little guy on the track? Mm-hmm. So when t equals 0, when t equals 1, oh, we don't know 1. That's disgusting. That's why I said think angles, right? Because you're plugging into trig. So how about when t equals pi over 4? I don't like that one either. What's something that I would like? Pi over 2? Okay, so when t equals pi over 2, right? Because then I can go ahead and plug in and get 0, and 1 times 5 is 5. So now I'm here. Wouldn't that also, well, I mean, with some degree of approximation, wouldn't you guys guess that it was going this way if that was the next point and the next point and the next point and the next point? And couldn't this little guy be going around in circles, around, around, around? Why is this a function? You plug in one time, you get out one position, 1x, 1y. So unique time, or I should say one input gets a unique output. So when would parametric equations not be functions? If at one time you were in 2 places. How physical is that? Don't answer that in any weird, just no, it's not. Okay. For what we naturally see. Kathy, though, you guys were laughing. What? What's up? Hannah. Oh, I have to see this? Oh, no. What did you just put in? And now I'm graphing it? You guys want to see how bad parametric mode can get? Ready? Go to your window. Go to like 6 pi. Go to your window. Go to like 6 pi. Go to your t step. And I want you to go by 5s. No, don't go 6 pi. Go like 60 pi. Go like 60 pi, and then go by 5s. So you're going almost a full 2 pi every time, and then graph. Yeah, it is. Why? Why is it going crazy? He's trying to do something. Why is it crazy? The picture, it was supposed to be an ellipse. That's not an ellipse. Why is it all like points and jagged and everywhere? And I just made that up. How long does it take to find coterminal angles? 2 pi, basically. I mean, kind of like it repeats 1. But every 2 pi, it's going to repeat, right? Because it's trig. But when are you checking in on it? 2 pi is 6.28, and when are you checking in? Where are you at 0? Where are you at 5? Aren't you pretty much at the end of the journey? And your calculator's going to say, oh, you're here. And then all of a sudden, you're here. And then you're here. And then you're here. And then you're here. And then you're here. Why isn't it getting me the ellipse? I need to take baby steps. Yeah? What if your mom's really paranoid? You leave the house. If she really wants to know where you are, let's just forget the whole GPS tracking thing for a second. You're like, well, I turned that off a long time ago. Anyway, coming back. But let's say she's not tracking you. She hasn't shared your location on whatever. Okay? How does she know where you are? Let's say you tell the truth all the time. Which you should do, but anyway. Okay? She calls you an hour later. What could have happened in that hour? You could have gone here and here and here. Okay, well, in LA traffic, maybe not that far, but either way, like you could have gone all over. If she wanted to know where you were, what would she do? Either stay on the phone and be honest about where you are at every second of every point, or call you every 2 minutes, right? Right? 2 minutes, every 5 minutes, every 10 minutes, even every 10 minutes. I mean, she should have a pretty good idea who you are if you're telling the truth every time. Does this make sense? So if I'm trying to follow the path of something, and if every 2 pi it's repeating, I need my t window. So why am I telling you this? If something were to ever go wrong in your graphing and you're like, why is it all jagged on the AP exam? What's wrong? Your window. Now pause. I want you to change your mode. Can you go to degree mode? Keeping the t's exactly as they are. Keeping the t's exactly as they are. Keeping the t's exactly as they are. Go to degree mode and hit graph. Why is it an ellipse? Okay, yeah, but why is it half an ellipse? What's 60 times pi? Isn't that like 180-ish? Oh, it's only because it's degrees. Do I mind going by 5s in degrees if it takes 360 degrees? See? So t equals 5 can be horrible for radians, but t equals 5 can be great for degrees. Why? It depends on the context as to whether they're baby steps or not, as to whether you can follow the path or not. Well, typically I would say we're supposed to be in radians, and the nice thing is, guys, go back to radians with the nasty t's, and then hit zoom trig. There actually is a preset that will at least get it somewhat accurate for the degrees or the radians that you're in. So if you were ever to have a weird window, something funky happen, if you were in degrees with radian measurements or in radians with degree measurements, zoom trig would at least get you kind of back to where you had to go. Does that make sense? Oh, because degrees, it takes 360 of them to repeat. And so your full path, well, it depends on the function, but this one, 0 to 2 pi, you'll get all of your different angles. So 0 to 360, you'll get your full path, and then it'll start repeating. So going by 5s will check in a lot of places along the way. Does that make sense? And 60 pi is 80, so it doesn't go the full way. So wait, does that mean that if you were in radians right now, zoom trig, what if, I don't know, 3 pi over 4? Could you not get the full path? T max. Make your T max 3 pi over 4. How much of the path do you get if you only graph 3 pi over 4? How do I know it's only going to graph that much? How do I? 0 to 3 pi? Are you in radians? You reset it? Why does it cut it off? Because your t's tell it when to start and when to stop. Oh, change your step. Change your step back. There you go. Okay. So guys, what if I was to give you this one? I want you to graph this with an appropriate window. You ready? Graph this with an appropriate window. What if x is equal to 'Try to get me a good picture of that path. It's a little nasty. I shouldn't go secant tangent yet. It's going to be hyperbolas. I feel mean. Go cosine sine again. The point isn't trying to make it nasty on you. I apologize. How's your 0 to 2 pi working? For getting you the whole path. You know it's supposed to be an ellipse. Get me the whole path. I think it's tiny. I think it was supposed to be that small. Let's make them both over 8. Did I have too much fun? Let's make them both over 8. Now what? This should be more normal. It should be an ellipse with a x radius of 4 and a y radius of 2. How do you get more? Remember, time steps. Huh? But Zoom standard doesn't work. Why doesn't Zoom standard work on this one? Why can't you see the full ellipse without expanding your t's? Uh-oh. Oh, you're still going by 5s, and you're in radians. So go to Zoom trig to reset for radians. Oh dear, it's even worse. Huh. You're in radians. That's weird. Yours doesn't do it. You might have to do it manually. Oh, sorry. It is working, because you have to expand your t's. Have you guys tried 0 to 4 pi instead of 0 to 2 pi? Have you tried 0 to 6 pi instead of 0 to 2 pi? Have you tried? Well, it's showing you more, though, right? Keep going. Get me the full ellipse. How far do you have to go? Have you tried 16 pi yet? Whenever you have a division or multiplication inside, whenever you have a division, instead of taking 2 pi to complete, it's going to take 16 pi to complete. So try 0 to 16 pi with a t-step of 0.1 or 0.5 or even 1. Now do you have the full path? So is there something that maybe we might have to review some trig along the way with parametric functions? But do you guys see what I mean as far as number 1, why are these functions? Because one time gives one location. It is somewhere, and you can use a little circle with the tail to see where it is. It could be that this thing is going around and around and around and around and around, which is going to be also nice to have that little circle so you could see it like complete one revolution. But depending on the period of the trig function, your t window might need to change. And they might give it to you or they might not. What would be different if I said instead of t over 8, what if I gave you parametric functions of the exact same for cosine, but at this time I did 2t? What just changed to the period? Instead of becoming 8 times longer, now it's so if you go from 0 to 2 pi or you're 0 to 16 pi, now if you just change that little thing, every pi it's going to be repeating, so it's going way faster. Does that make sense? Okay, so periods are going to help. You guys seem lost. Have you been following clues? Oh, you're good? Okay, just checking. So let's get back to the calculus. That was just like the pre-cal. And don't you guys have notes about parametric, like from the beginning of the year, pre-cal stuff? How do we find dy dx? How do we find, wait, what's the meaning of this? What it's always been, slope of the tangent line to the path to your ellipse. Ooh, so we can do slopes to ellipses now. That's fun. So how do we find dy dx using parametric equations? Y prime over x prime. So hold on, in context, this would be the slope to the path. Sorry, I'm saying slopes because they're general. So the slopes to the path, right, the tangent lines. So if you were, for instance, doing like a discus throw, right, and the path was your movement, I'm going to hit something, the tangent line could be like, hey, if you were to release right here perfectly, where would it go? That could be dy dx. Where would it head? Where would it go? It would go along the tangent line trajectory. That's this, but what are these? What's y prime? Yeah, but that gets awkward, right? Because it's not the slope of the ellipse, so it's the slope of just the y's. Why don't we just say it's the rate of y? Or the vertical rate. How are the vertical positions or the vertical displacements changing? How fast is it changing vertically? And then we could say instead, this is the rate of x. How fast is it changing horizontally? Have any of you guys, oh, sorry, horizontally. Have any of you guys ever, I shouldn't give this ride because I've never been on it. Goliath. Okay. You've ridden Goliath at Magic Mountain. That big, long, you feel like you're going to hit the ground when you're going down, right? The big, long drop. How fast are you changing horizontally when you go in the drop? Barely anything. I don't know if it's truly a 90-degree angle. Like Superman would be at the beginning, right? That's just a straight drop. But Goliath is going to be a little bit curved. But horizontally, you're barely changing, right? Like horizontally, you're barely changing. But doesn't it feel like you're going fast? Why? Horizontally, you're not changing fast, but how are you changing quickly? That's going to be huge. That's going to be tiny, right? So that's what I mean by two-dimensional motion, because now that we have things moving out, moving up, moving over, they're going to be defined separately as far as the horizontal position, the vertical position, the time it's happening at, the rates of speeds. But remember, we can still put them together to talk about the slopes of the tangent lines. Second derivative. The problem is the physics day is right in the midst of like our AP cram session. No, but the physics day. It's technically a middle school math day that physics is like, oh yeah, we'll go do math. Anyway, it's really like middle school math. Come back. How do we do the second derivative? You guys remember from your forever card? Because this was a forever card from last, endeavor card from last semester. Yeah, of this, not of y prime, of the whole derivative, because it's going to be in terms of t, right? Everything has t's. So take the derivative of in terms of t. The derivative of in terms of t's, remember, we get d squared y over just dx. Remember, we have to divide by dx dt to make it width, to figure out the concavity of the path. We have to, in a sense, disregard the t, because this will be d squared y over dx dt dx times dt. If I divide by a dx dt and flip it, I get dx squared, like the dt's will cancel. It's all about kind of like dimensional analysis in some ways. So how do we apply it? Well, okay, sorry. We already have this, right? This notation is awkward. I don't think the AP ever makes you deal with this, but saying let's just name this y prime, I don't like that. It's confusing. Let's instead see. Let's keep our endeavor card, and let's try to apply to a problem. Consider the curve defined parametrically by x equals t squared minus 5 and y equals 2 sine of t. One's trig, one's not. Okay, whatever. For t between 0 and pi. Whew, that's good. I don't have to think about it. A, sketch the graph of the curve in the viewing window. Yay, we can use our calculator. Okay, I didn't make a big deal about you guys doing it, so we're going to play with our calculator in the beginning. So what's going on when they tell us negative 7 to 7 and negative 4 to 4? They didn't label it. What do they mean? Does that make sense? So we can do x min, x max, y min, y max, and then t min, t max. Are we okay with just what they told us? We would go to our window, change all of our stuff. We're in radians, always radians. Sketch a curve of the sketch a graph. Oh, okay, and I already put it in. If you guys want to put it in, you can as well. When they say indicate the direction in which it's traced, that's with the little circle with the little tail. Which way is he going? But guys, couldn't we also just do some math? For instance, when t equals 0, where is this thing? Can we just plug in? Negative 5, 0. Isn't it here? And if this is our curve, where are we going to assume it's going? Now, if you graph it, you should be able to see it going this way as well. Now, here's something interesting. I wonder what it's doing. Is it just going like forever this way? Does it bounce back? Oh, things can bounce back? That's cool. Anyway, indicate the direction in which it's traced. Find the highest point on the curve. Oh, easy, easy. You're in par mode. Isn't there a max feature? Sweet. Ready? Second, trace. Find the max. Highest point, max value. If you ever want it to stop, hit the on button, it'll break the code. It'll say stop doing whatever you're doing. Can you find the max? Maybe. What if it was 1.98? Second. Trace. Exactly. Say it out loud. Say it out loud. Riley went to go find the max and she said, wait, what? And I said, say it out loud. She's like, I don't know. What's wrong? It's a different list. Parametric mode doesn't have a max or an intersect or a min or a, it's okay. We know calculus. How do we find the max without tracing and hoping that we're right when we get there? It's a critical number. But wait, do I set y prime equal to 0, x prime equal to 0, or dy dx equal to 0? Now, in context, dy dx equal to 0, what's going to happen at the top of something's motion or at the top of something's movement? Can your horizontal rate still be going at the top of motion? Remember what I'm saying? Didn't we always say that at the top, the derivative's always 0? But if it's going out now, is the x prime 0 or the y prime 0 or both? Why is it just y prime? The x is still moving. You're still going to the right. The x is going to have a positive rate the whole time. But the y rate, it was going up, and now it's going down. To change direction vertically, what has to happen in between by IVT? 0. It might have been shot up. If it was shot straight up, x prime would be 0 to start. But if it was shot out, x prime could start with a number. Does that make sense? Like an initial velocity. Yeah. But if it lands, I don't know if it lands or if it starts doing a horizontal asymptote. I kind of feel like it's a horizontal asymptote. If you make your t longer, you could see what the circle does. If it lands, then yeah, y prime and x prime would both be 0. Or if it smacks a wall and doesn't travel into the wall. But guys, mathematically, doesn't this also make sense? Wouldn't the slope of the tangent line be 0? And for the slope to be 0, don't we only set the numerator equal? So we could expand the idea, and we could be like, oh, hey, in parametric motion, y prime equals 0. But your dy dx equal to 0 would say y prime equals 0 anyway. But did I even need to find the whole thing? No, forget it. Just take y prime and set oh, sweet, okay. Y prime equals 0 when? Which is, stink, cosine. Well, not in between that window, though, right? When's cosine 0? Pi over 2. So pause. What if, can you do value in your menu even though you can't do max? Can you do value? If so, go do value at pi over 2. It better be at that height. But hold on, pause. Was this asking for when or how high? Now, it technically says find the highest point. So what would the highest point be? Wouldn't it be x of pi over 2 and y of pi over 2? So Arian, yes, it wanted value, but not just of y. If it said when, yes. But since it says point, we have to think, we're talking about 2 dimensions now. So we're not just saying at time the highest is, we're not just going up and straight down, we're also going out. So we have to say the horizontal and vertical positions. So at pi over 2, did you guys figure out that it was at 2? Y, but what's our x? Ooh, is that with decimals though, Riley? Is it 0.500? 329. Okay. 599. Sorry, start at the beginning. Sorry. Negative 2 point.
Okay, 532. Is that what you
Oh, and then after the 2 is a 9? Okay, but it still rounds up though, right? Okay, got it. I was just trying to get my 3 decimals. No, you're good. You were trying to get me the whole decimal. But since it's my final answer, I can stop. Now, if it said the highest height, I would just give the y. Said something about the horizontal displacement. I don't know. Anyway, justify your answer. What can our justification be? Anything from the slope of the tangent line will be 0, therefore dy dx equals 0 at. But we could also say something about at the highest point, our vertical velocity or our vertical rate will be 0. So y prime equals. But guys, the AP probably won't ask us to justify something like that. This is just a book problem trying to be like an AP problem. What's going on in letter C when it says find all points of inflection on the curve? Second derivative equal to 0? How do I find second derivative? Yeah, which means I need to find the first derivative, which I didn't actually do, right? So I'd have to do d dt of, what is my first derivative? We took y prime. I'd put that over if I was doing the full derivative. 2t. But isn't that just half of the formula? Isn't the second derivative the derivative of the first derivative all over x prime again? Careful. It's going to be easy to forget. Oh man, how do I do the derivative of the first derivative? Yeah, it's a quotient. So bottom d top, 2 times negative 2, negative 4 sine t, minus top d bottom. Oh, 2t. Aww. Negative 4t sine of t, minus top d bottom, which will just be 4 cosine t all over bottom squared. Well, can't I do 4t squared and combine it with that guy to be 8t cubed? Is that okay?
Yeah.
Find the zeros. How do I find the zeros? Didn't we use the calculator for this? Okay, so we can use the calculator for that. But how do we do that in parametric mode? Like, I can't even find maximums and minimums in parametric mode. Switch to function mode. You can graph this as a y1 in function mode, and can't you find the zeros in function mode? Use t as x. What are we doing? Making the tool work for us. Parametric mode is great for visualizing. Not so great for solving stuff. Function mode, much more to be desired. You guys see what I'm saying though? Wait. Remember in function mode, can't you make your x min, x max just look between 0 and pi? You can do zoom standard because it's going to hit the x-axis. I don't care how high or how low it goes. I just care about its zeros. And you can make your x min 0, your x max pi. You're looking for intersections with the x-axis, right? Wait a minute, if we're graphing it, why can we also use that for our justification? Aren't we looking at the second derivative, being above, being below, being below, being above to above, or below? Can't we say the sign changes if we see it crossing through? Sweet. So do you guys have any zeros that aren't just zeros where it bounces off the axis, but where it crosses through the axis between 0 to pi of this function? No? It's okay, I haven't done it before. Well, I mean, I have, just not this year. Do you guys double check my derivative though, right? Like I'm not going crazy? Or I didn't make a mistake? Make sure you're in radian mode. 0 to pi. You're using your nice nifty fraction feature to make sure everything's like in there okay, right? And then sine of x minus 4 cosine of x all over 8t cubed. Graph. I went from 0 to pi. He goes up, he goes up, he goes up. Ah! Does he cross? Oh man, I don't know if he crosses. I'm going to make my t window go a little bit out to see if he goes above at any point. And maybe I'll make my y min, y max a little bit smaller. For those of you guys wondering, it kind of looks like it's going to a horizontal asymptote, like it doesn't have any crossings. So I'm expanding my x to make it go even further to see if it actually goes above the axis at any point. It's skimming. I don't see it going above the axis. Do you guys?
Yeah. I keep saying error.
Yeah. You want to check? Double checking our derivative real fast. Derivative of 2 sine is 2 cosine, 2t. Quotient rule, bottom d top is a negative. Minus top d bottom is just 2. All over bottom squared is 4t squared, 8t cubed. If I pull out a negative, if t's are only positive, wait, this makes sense. It's always negative because a positive number will always be positive. That negative comes out. Sine and cosine, the biggest they can be is 1 or -1. Yeah, it's not going to flip the sign. So what does that mean? No points of inflection. Man, these questions are worse than the AP. Justification. Can't we say no sign change of the second derivative? We don't even have to say like none as in anywhere, just in case we're wrong somewhere else, but we can say on the interval. If there was a sign change, could we have found it, though, in function mode? Yes. Does that make sense, kiddos? Ooh! So why aren't we just done today and I say just go do homework? Well, we have a few more practice problems, but what's something I want you to write down first? A new endeavor card, please. I think we're at 27? No, 28? 30? We're at 30? Okay. Can't remember when the last quiz. Uh-huh. What were the extra ones? The Taylor-Maclaurin series? Just throw him at the end. Yeah. And then that'll be 29 to 30. That's okay. That's okay. Oh, my nutrition snack. Need my protein. What do you guys see? Length. Wait a minute. We've done length. Arc. Oh, up too fast. Arc length. I'm getting old. Arc length. This doesn't, I don't know. My knee's been wigging out. I think it's because I'm running weird because this thing on my foot. Anyway, shout out. Anyway, coming back. Arc length. It wasn't this though, but it was close. What was it? It was an integral. It was an integral of a square root of a 1 plus. Wasn't it 1 plus f prime? Well, this is kind of like that. I mean, it's a little bit different, but it's kind of similar. It's kind of distance formula, kind of not. But guys, it's at least similar. Like without me showing you exactly where it came from, it's at least similar, right? And couldn't we technically kind of like divide by x prime and divide by x prime? That would be a 1, I mean squared. That would be a dy dx squared. The weird thing is then you're like, wait a minute, but then I'd have to pull out like a square root of an x prime squared. Gets a little bit weird. It kind of breaks down. But it's super similar to arc length. It's just applied to a parametric curve. But when on earth could they expect us to do this, or would they ask us to do this? Do you guys see the example right below it? Right, but to not evaluate an integral, giving the length of the path. Oh, so we could figure out how long that ellipse is? Oh, wait, they gave us something else. Okay, fine. How long this thing is from 0 to pi? Yeah, no problem. All we got to do is just know our formula to go ahead and plug in 0 to pi. Hey, it's like a total distance traveled one on the AP. It's free points if we know the formula, right? So what do we plug in? We love free points. Right? Okay, so we should probably get that one done. But it's super similar to arc length. You guys kind of get what's going on? This one says there's an elliptical path, travels along the line tangent. Ooh. Anyway, we got a lot of vocab down. We got a lot of like parametric review and calculator stuff. Please start homework. So tomorrow when I say like, hey, where have we gotten stuck? Do you want to talk about it? You have things if you've gotten stuck. Sound good? Bye, guys.